In our previous lesson, we looked at linear inequalities, so it makes sense. The next step from there would be looking at nonlinear inequalities. As we did before, we're going to start by looking at this graphically. And in this case, I have the inequality x squared minus 3 is less than 1. So if I wanted to look at those graphically, what I would do is I would graph this x squared minus 3, that's a quadratic, and I would graph this. So in essence, I am going to be graphing y equals x squared minus 3, and I'm going to graph y equals 1. So when I do that, let's go ahead and put a scale on here. So I know that, well, first of all, let's put a scale on. So I'm just going to use each of my dashes will count for 1. So that would be 5. And negative 5. And 5. And negative 5. So x squared minus 3, that's a parabola that has been shifted down by 3 units. So the new vertex of this parabola is right here. And I'm going to use the step pattern to very quickly and easily graph that. Over 1, up 1. Over 1, up 1, 2, 3. And over 1, up 1, 2, 3, 4. And it's not going to fit on here. It would be around there. By symmetry, I would get something like that, and then left 1 and up by 3, and then left 1 and up by 5. And once again, that's taking me off the top of the graph, but I can certainly approximate it there. Now the downside with spreading your graph out here is it makes it tough sometimes to draw your parabola nicely, and do my best. That's not bad. And going the other way. Now remember, when you do these things graphically, there's also a tendency for you to get inaccuracies unless you have a graph that is so precise that you get nice crossings of your points. Now in this case, we are going to be lucky enough to have that, because the other line we have here is the line y equals 1. So the line y equals 1, here's y equals 1. So this is just a horizontal line. That's as poorly drawn a horizontal line as I can imagine. How about I do it this way? Horizontal line there. And I'll just put some arrows on the end of that. So there's my horizontal line, y equals 1. Now having done that, I want to know when is the blue parabola lower than the black line, y equals 1. And so where does that occur? Well, and again, the key here, something that's a key to this, it's less than 1. So we see that happening here over to here. So let me go ahead and get my highlighter. So we are interested in that section of the parabola. And where does that occur? What x values? Well, if I come down, I end up at this x value all the way over to this x value, and I've drawn open circles because it doesn't include those values, because we're looking at less than, not less than or equal to. So I end up with, this is negative 2. So if I just were to write this using a fairly casual notation, I get negative 2 less than x less than 2. If I want to write that using set notation, a little bit more formal, x member of R such that negative 2 less than x less than 2. If I wanted to write that using interval notation, x is a member of the interval. It's an open interval, which means I'm going to be putting round brackets on both sides. And here's another little thing that you may or may not recognize. This one, negative 2 less than x less than 2, there's actually another way I could have written that, which is the absolute value of x is less than 2, if you think back to our lessons on absolute value. So all of those are solutions. The best of these solutions are those two from a communication point of view. So that's a graphical solution, but you're not always going to get these nice intersections, or even when you do get a nice intersection, you might not be able to see that from your own representation of the graph. So as usual, we are going to want to explore algebraic options as well. So to do this same thing algebraically, the best way to do this is, rather than look at the inequality in the form that it's given to you, we're going to use our rules for algebraic manipulation of an inequality, and we're going to manipulate it until one side is 0. So let's start with that step. I'm going to manipulate this so one side is 0. Easy enough. I'm going to subtract 1 from both sides. X squared minus 4 is less than 0. So asking yourself, where is this graph less than this graph, is the same as asking where this graph is less than the line y equals 0. They're equivalent. And then I'm going to figure out what the zeros are because I'm going to use the zeros to create intervals. So in order to know zeros, I have to factor this as far as I can. This is a difference of squares, pretty easy to factor. That's x minus 2 times x plus 2 less than 0. Now, that means, obviously, this is not an equation equal to 0, but if we had the equation equal to 0, then what would the zeros be? So in this case, my zeros would be x equal positive 2, x equal negative 2. So now that I know those zeros, I know I'm going to be testing around these values. And so I'm going to test each interval. So I want you to think about, what intervals can I have? And let's, I think I'm going to draw a number line here to give you an idea of what we're talking about. I think that's the best way to visualize it. So let's go ahead and put, so there's 0, 1, 2, and let's say 3, negative 1, negative 2, negative 3. And we are interested in the values, and I might as well do this properly. It's a less than. We're never going to be equal to 0. It says less than 1, which turned into less than 0. So we have negative 2 is of interest to us, and positive 2 is of interest to us. So where are the possible intervals that I will check? Well, I'm going to check everything to the left of negative 2. I'm going to check everything to the right of positive 2, and I'm going to check between negative 2 and positive 2. And what we want to do is we want to pick a test value. So we're going to pick a test value that is between, or that represents each of those intervals. And the test value itself doesn't actually matter so long as it is on that interval. The interval itself will be consistent. So for example, a logical test value here might be negative 3, but I could choose negative 4 or negative 5 or negative 3.2 or negative pi. All of those things would be valid test values. A very logical test value here might be 0, and over here I'm going to test 3. All right, let's go ahead and perform those tests. So what I want to do is see, when I take this value of negative 3 and I put it in here, what do I end up getting? Do I get something that's less than 0 or greater than 0? So my left side, which is equal to, and I'm going to write it out just this one time. I'll actually rewrite out the x minus 2 and the x plus 2. And I'll put a negative 3 in there. Negative 3 minus 2 is negative 5. Negative 3 plus 2 is equal to negative 1. Now you might notice I didn't actually put the negative 3 in there and show it. That's because I actually, above here, I say I'm testing negative 3. If you don't have this written explicitly, then you better show me the value that you're putting in there before you get these results. And negative 5 times negative 1 is equal to positive 6. So do you think this test passed or failed? Is that a number less than 0? No.